Over the next several days, we're going to be learning about something I call universal science concepts. These concepts are things that are important in all the sciences. That's why I give them that very special name. It's going to take us a few days to get through all of them. They'll pretty much be review probably for most of you, but just in case they're not, I'm going to go through them like you've never seen them before. We're going to start with scientific notation. One of the things I want you to realize is if you look up here in the corner, you're going to see a little guy writing on a package. This is my way of indicating to you that I would think that you should write this down in your notes. Get it? It's somebody writing, so therefore go in your notes. So whenever you see one of those, that is a slide that I think is something you might want to take note of. You don't have to do that, but it's just strongly encouraged if you're the note-taking type. Notice when you look at this slide, there is no little package in the corner, so you don't need to write this down, but doesn't mean this isn't important. Scientific notation enables us to do great things. It's very powerful. So it allows us to represent really, really big numbers or really, really small numbers in a more convenient way. If I want to write the number 1 billion, it's so much easier to write it in scientific notation than it is to write 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. So that's why we use scientific notation. My having said that, though, you realize that the Regents people will put the bizarrest numbers in scientific notation. They'll put the number 25 in scientific notation. For some reason, it makes them happy. I don't know why. But we need to be able to read it no matter what number they put in scientific notation. As you can see here, you need to be able to interpret numbers that are already in scientific notation, and you also need to be able to put numbers into scientific notation if they're not, depending on what situation you are confronted with. So we'll start with simply reading scientific notation. The number is already in scientific notation. What does it mean? A number that's in scientific notation is going to be in this format. Now I say that, and I want you to note that there's a mistake here. It's 3.45 times 10 to the minus 5. This part is supposed to be a superscript, but unfortunately when this program uses a PowerPoint, it gets rid of that formatting for me. So understand this should be to the minus 5. That should be raised up there like that, not down here like this. So if you're writing this in your notes, like you should be because the little guy with the package is down here, you should be writing it as 3.45 times 10 to the negative 5th power. So I'm going to correct these every time we come across one in this, this program. So the big number here that's important to us is the exponent of 10, which of course should be up here. The exponent of 10 is going to be what we have to focus on to figure out how to put it back in regular number. Because the exponent is negative, a negative 5, in fact, it tells us that we need to move the decimal point in a particular way and a particular number of times. The negative means we move it to the left, and the number 5 tells us that we're going to move it 5 places to the left. So 3.45 times 10 to the negative 5 means that we're going to take this decimal place and move it, we're going to move it 1, 2, 3, 4, 5 places. 5 places gives us 0.000345, like you can see down here. We moved it 5 places to the left. Here we have another example. This one is 5.1 times 10 to the 4th. Again, that should be an exponent. This time it's a positive exponent, so that tells us something different. If we have a positive exponent, that means we must move it 4 places to the right because positive is right. So therefore, we're going to move this decimal point 4 places to the right. Here you can see I tried to fix that mistake with the exponent, but it looks ugly. Anyway, I tried. So 5.1 times 10 to the 4th, you move the decimal point over 1, 2, 3, 4 places, so you get 51,000. Makes sense, right? What I'm going to do now is I'm going to do a couple of more examples. You don't need to write these down. Even though the guy with the package will appear in the corner, this is just for practice for those of you who are maybe a little uncertain with what you're doing. Look at this. I'm getting better at this. It almost looks like it wasn't wrong to begin with. How about 7.6 times 10 to the minus 2? Well, we know the negative 2 means that we're going to have to move the decimal point 2 places to the left. So if I have 7.6, move the decimal point 2 places to the left, it is going to give me 0.076. Please note that we will always put a 0 in front of a decimal point like this. Rather than writing it as 0.076, we're going to put 0.076. This 0 here makes it so that I won't lose track of that decimal point that is there, because sometimes you lose sight of those if you're writing really fast. Okay, so we know now how to convert into regular notation. Now we want to convert into scientific notation. So this is our second topic for the day. When you have a regular number, you have to think backwards of what we just talked about. Let's try converting 0.0028 meters into scientific notation. The first thing we have to do is we notice that this number is less than 1 because it's 0.00. And if it's less than 1, then the power of 10 must be negative. This will always be true. If it is less than 1, the number is less than 1, then you must have a negative power of 10. So what we will do here is we'll count the number of decimal places that we're going to need to move the decimal point so that we end up having just what oh, I love this thing. So we end up having just one non-zero digit to the left of our decimal. So in this case, that non-zero digit will be the 2. So our decimal point is going to end up going right there. If we want our decimal point to end up going right there, how many places do we have to move it? Well, it looks like 1, 2, 3. So as you can see, what we end up with then is 2.8 times 10 to the negative 3 meters. Oh, wait a minute. Get rid of this because this is not properly noted. And make it negative 3 like that. I really hate the fact that this program messes up my scientific or my exponents. Oh well, such is life. Let's try doing 831,000 and converting that into scientific notation. Remember, we need to have it so that we want to have the decimal point between the last 2 digits there, so that there's only one non-zero digit to the left of our decimal. So how many places do we have to move it? Well, let's see. Looks like 5. 1, 2, 3, 4, yep, 5. If we have to move it 5 decimal places and this number is bigger than 1, then we're going to have that exponent be, because remember the exponent is only negative if the number is smaller than 1. So therefore this number becomes 8.31 times 10 to the 5th kilograms. Make sense? I hope so. Let's look at another. What if we have 12.6 centimeters? Remember, I told you scientific notation is great for numbers that are really big or really small, but this is the kind of thing that the Regents will do. They'll want you to put this into scientific notation. Well, the first thing we have to do is make sure we only have one non-zero digit to the left of our decimal point. So that means our decimal point is going to want to go right there, so that only the 1 is to the left of it. And if our decimal point goes there, we only have to move the decimal 1 place, correct? Just like that. If we only have to move it 1 place and this number is bigger than 1, then it's going to be a positive exponent. So therefore, we get 1.26 times 10 to the 1 centimeters. Whoops, let me fix that. There, I fixed it. How does that look? Perfect. 1.26 times 10 to the 1 centimeters is the same thing as 12.6 centimeters. Do we have any questions? It's going to be tough to ask me because I'm a video, but if we did, we'd have to write those down and bring them to class with us tomorrow so I can answer them then. Now here's great news for you. The calculator will do the work for you. And what I'm going to do in class is show you that. So for now, we are done.